Welcome to Simply Pi Maths.
Probability. So in this video we will learn how to find possibilities of any given event. Also we'll understand some basic concept of sample spaces. Okay, so let me quickly just write a question over here. So the question says how many possibilities are there, and the very first question is any day of a week to be selected. So let's understand what does this mean at the first place. So any week, any day of a week is to be selected. So you all know in a week there are 7 days, right? In a week there are 7 days. So if I ask you to select one day, you might select Sunday. Someone might select something else like Thursday. Someone else say there is like he likes Friday, correct? So how many possibilities are there? That's what the question is. So the maximum number of possibilities is 7, isn't it? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Other than these options, there is no other option left out, right? So that means we will say since there are 7 days in a week, therefore in this case how many possibilities will be there? Just 7 possibilities. So we will say there are 7 possibilities. Simple as that. Let's see the next sum. So the next sum says one number from 10 to 20 is written on each card. Select one card randomly. So let's understand here this sum. So it says one number from 10 to 20 is written. 10 to 20 is written means what? So example, I am taking a card and I am writing 10 over there. Then I am taking another card, I am writing 11 in it. So I need to write from 10 to 20. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and finally 20. So if I just count how many cards are there inside this. So let's say if I do the same experiment over here, right? I ask you to select one card randomly. Someone might select 14, someone might select 12, or else someone might select the very first number 10, or there are n number of possibilities, right? Let's see how many possibilities are there, how many such numbers can be selected. 1 2 3 4 5 6 7 8 9 10 11. So there are 11 cards, so 11 possibilities. So I will say since there are 11 cards from 10 to 20, so therefore there are how many possibilities? 11 possibilities. Clear? Now let's see another variety of sum which says write sample space S and number of sample points n of S. So first of all, how to read this thing? So this is supposed to be read as n of S. Okay, so it should be read as n of S. We'll try to understand what is this n of S at the first place, and before understanding that we should understand what is S, that is sample space. So let's see an example over here. It says one coin and a die is thrown simultaneously. So whenever we toss a coin, right, what is the maximum possibility that can be expected? Either the coin will show me head or the coin will show me tail, right? And when a die is thrown, what are the possibilities over here? The die can show me the number 1, or the die can show me the number 2, or else it can show me up to number 6, right? That is the maximum that I can see in a die. So 1 to 6 numbers can come out of a die, and from coin there are just 2 values expected, heads and tails. So now the experiment says we are tossing a coin and we are throwing a die simultaneously. So I could say in coin I saw head, but in die I saw 2. So it can be a combination of head along with 2, isn't it? There are n number of combinations. I can also say like along with head I received something like 6, head and 6. This is also a possibility. Someone might say I didn't receive head but I received tail. With tail I got some number, let's say 3. We could see 3 also, right, in the die. So I could say tail and 3. So what I need to do is I need to write all the possible combinations which are possible in this experiment. So the easiest way, the easiest pattern will be, first of all I will list down all the values with heads, like heads with 1, heads with 2, heads and 3, heads and 4, up to heads till 6. Then I will repeat the same thing with tails. I will say tail with 1, tail with 2, tail with 3, up to tail with 6. That means I will not miss out anything. Okay, so let me just write it in a proper way over here. So I will say along with head, let's say I got 1, then along with head I could get 2 also, along with head I could get 3 also, along with head I could get 4, or head and 5, or head and 6. So the same thing can happen with tails also, right? I will just write it over here below. Tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6. Other than these combinations, there is nothing else left out, isn't it? So let me just put a bracket over here, closing these elements inside a bracket. This is called as sample space, and we should name it always as S. S for sample space. Now S is found. Now they need n of S. Let's understand what is the meaning of n of S. It is nothing else but you just have to count the elements inside this set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 people inside this. So n of S is 12. Simple as that, right? So let me just proceed to the next sum in the same way. So let's see what the next sum says. So the next sum says 2-digit number formed using 2, 3 and 5. I need to form a 2-digit number, okay? 2-digit number means what? Using these 3 numbers only. That means I could create 23, right? 2 and 3, 23. I could create 53. This is also a possibility. Or else I could create 32. This is also a number which I can create out of this. But it says without repeating the digit. That means you cannot use 2 twice, like 2, 2, 22. 2 is there, so I am just using it twice. This is not possible in this because they are saying without repeating the digits. So 22, 33, 55, such repetitive numbers are not possible. You have to select one number, then the other number, select one number, then the other number, and so on. You have to create all the possible 2-digit numbers. So let us use a pattern over here to make sure that we are not missing out anything. So how I can do that? First I will catch this 2 and I will combine it with 3, that is 23. In the same 2 I will take it to 5, so it will become 25. So this is done. So I have 2 to 3 and 2 to 5. I will do the same with 3 now. 3 to 2 and 3 to 5, so it will become 32 and 35. And finally I will do the same with 5, 5 to 2 and 5 to 3, so it will become 52 and 53. There is no other possibilities left out. I will close this bracket and I will name it as S, that is my sample space. And as the sum says, they need n of S as well, right? So let me write n of S. So in this case, what will be n of S? 1, 2, 3, 4, 5, 6. N of S is 6. So let's see the next question. So this question is a bit different. So they have given us a disk and it has an arrow over here, and this arrow is in such a way that I can rotate this arrow. Okay, so the question says the arrow is rotated and it stops randomly on disk. Okay, that means what? I will just rotate this arrow and this arrow will start rotating. It might stop at any one of this color. Okay, the question says find out on which color it may stop. I need to identify like on which color this can stop. Okay, so let's take it step by step. So first of all, when I rotate this arrow, on which color this might stop? This might stop on red, this might stop on yellow, or this might stop on green. It can stop at any one of these colors, right? So if I start listing down the possibilities, so I can start from red. It is your choice, you can start from any of these color. I may say like it might not stop on red, it might stop on orange. So I am just listing down all the possibilities. It might stop on yellow. So in short, we have to just list down all the colors over here. Blue, blue, what else? Green, green, purple. Are we left out with anything? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have covered all the colors. I will put it inside a bracket and I will name it as S. So if I ask like how many colors are there, So there are 6 colors, isn't it? So I will say n of s is 6. But in order to answer the question in a proper way, it says find out on which color it may stop. So what I could say, the arrow might stop on any one of the 6 color, isn't it? So I will say therefore the arrow may stop on any one of the 6 colors. Simple as that. That's it. Let's see another example. So this question says find days on which the date is multiple of 5. So there is a calendar given in front of me. I need to find the days. Okay, so when I say days, it is nothing else but Monday to or else Sunday to Saturday. So these are the days which I need to identify, but they have put a condition over here on which the date is multiple of 5. So let's first of all understand this point. Date is multiple of 5. So date multiple of 5 are, let me list down all the date which can be a multiple of 5. So I can start with 5 onwards. 5, 10, 15, 20, 25, 30. I cannot write 35, right? Because 35 is not there in calendar, right? 30 is the maximum number which I can look for. So I have listed down all the multiples of 5, all the dates which are multiple of 5, and let me now identify these dates in this calendar. So 5 is here, 5, 10, 15, 20, 25 and 30. Now they are moreover interested with the days, right? Days means what? 5 is lying on a Tuesday, 20 is lying on a Wednesday. Let me come back. 25 is lying on a Monday. This 15th is lying on a Friday, and 30 is lying on a Saturday, and 10 is lying on a Sunday. So they need all these days to be listed down. Okay, so that means only Thursday is a day in which there is no multiple of 5. Okay, so let me just say that. So if I create a sample space, in sample space I need to put all the days because they are concerned about days, right? So I need to put all the days over here. So what all days I will write? I will write all the days except Thursday. So let me write like Monday, Tuesday, Wednesday, Thursday I will skip, Friday I will just write Friday, Saturday and Sunday. Once this is listed down, let me just say how many days are there, by the way. Except Thursday all the days are there, right? So 6 days are there. Okay, but in order to conclude the answer in a proper way, they are asking me find the days on which the date are multiple of 5. So I will say therefore days on which the date is multiple of 5 are, which are those days? All these days which I listed over there, right? I will say Monday, Tuesday, Wednesday, Friday, Saturday and Sunday. Simple. Let's see the next sum. So this is a form of complete the following type of sum. So it says there are 2 boys B1 and B2 and there are 2 girls G1 and G2, and I need to form a committee of 2 boys. So committee of 2 boys means a group with both the boys. So there are just 2 boys, right? So I can just simply say B1 and B2 inside a box. So it is a committee of 2 boys. There is no other option left out with me. Similarly, committee of 2 girls, I just have 2 girls, so I will put them together in a box. So I will say committee of 2 girls is G1 and G2. Okay, now this is a bit tricky one. So it says form a committee of 1 boy and 1 girl. That means I have to write all the possibilities where I can have 1 boy and 1 girl. So let's say I am taking this boy B1 with girl G1. So this is first committee, B1 G1. I could have took this boy 1 with girl 2 as well, right? So let me just put a second committee like boy 1 with girl 2. I could do the same with boy 2 also. Boy 2 with girl 1 and boy 2 with girl 2. Boy 2 with girl 1 and boy 2 with girl 2. right? So these are all the possibilities that I can have having one boy and one girl. So simply I took this boy with both the girls, like boy 1 with girl 1 and girl 2. Then as a second combination I took this boy 2 with this girl and boy 2 with this girl. So these are the possibilities where I can have one boy and one girl in the committee. Now finally it says sample space. So sample space means what? Basically it is nothing else but a collection of all these possibilities. Means the possibilities where both of them can be a boy, or a possibility where both of them can be a girl, or the possibilities where one boy and one girl can be there. So I will just list all of them over here one by one. So boy 1 with girl 1, boy 1 with girl 2, boy 2 with girl 1, and finally boy 2 with girl 2. So we are done.